So, as I mentioned before, the only thing different here from what you're going to be doing is that last night all of these were solved for a variable, and then tonight they're not. So what do we do when we come across system of equations when they're not already set up for you just to start substituting right away? Okay. Well, we're going to try to pick one, and we're going to solve and make it a variable by itself. We're going to solve for that variable. That's what we're heading towards today. So first off, I want to just be able to identify, well, of these here, right, which one is good for system of equations by substitution? A, B, C, or D? Okay, and what gives it away? Why is it better for substitution? Okay, so we can look here. Can't easily plug in one equation to the other for A, for B, C. But when you get down to D, you can see, well, yeah, this one has a y equals, just like last night's homework. So this is a good substitution method problem, because I can easily just take 3x plus 1 and plug it in for y and start solving. So this is our goal for all the first step for all the system of equations by substitution, trying to have one variable by itself for at least one of the equations. It doesn't have to be both, but it can be. Okay. Same thing over here. Which one would be really good to use substitution on? Yeah, C, because of the x equals, right? So we're not graphing, so it doesn't have to be y equals. We're so used to seeing y equals the slope, x plus y intercept, but we're not graphing, so we don't have to abide by those rules. If it's x equals, that's just as easy. I can take 3y plus 1 and plug it in right here, and I'm good to go. I can start solving. All these others, these are both in standard form, not quite as easy. Okay? Now we're going to have another method that's going to be perfect for standard form. We'll talk about that tomorrow and Friday. But for now, we're saying, well, what if we have one of them that's equal to a variable, or it's really easy to solve one of them equal to a variable? How can we solve it? Okay. So take this. Okay. Which one of these equations would be easy to solve for? A variable and get it by itself. The first equation, what variable? Which one's easier to get by itself, x or y? Yeah, probably x. Just have to do a little bit of work, move the 2y over. And what about the second equation?
Y.
Yeah, it's easy to solve for y here. You can move the 5x over, and now you have y equals. So we can either solve the top equation for x or the bottom equation for y. And let's just go through and show how that works. Try to get this thing window bigger. There we go. So you guys could probably just picture this in your head. Okay, now. There we go. But yeah, if I want to get x by itself, only thing I'd have to do is subtract 2y on both sides. And now I have x equals 15 minus 2y, or negative 2y minus 15. It doesn't matter if you put it here or here, one or the other. And then from that point, I can take 15 minus 2y, plug it into here, and go ahead and solve. So that's one possibility. As you saw on the other page there, that, well, I could also instead just solve this one for y, the second one for y, and I'd also have a variable by itself, and I could plug this one right here into the top equation for y. So it's two possibilities, which means when you guys come in tomorrow and you start comparing work, you know, you might have picked to solve the top one for x, your neighbor might have picked to solve the bottom one for y. Your work will be different, but then at the end their answers will be identical. Okay, just two different paths to get to the same answer. Okay. And that's only in the case where both of them are easily solving for a single variable. Usually just one equation is easier than the other. Okay. Of course, after this you'll go through and your final answer tonight will still be to get, you know, what is x and what is y, just like last night. Okay, okay, you guys give this a try. Which expression could be substituted for y in the second equation? So basically, solve the first equation for a single variable. Which one is that? And what do you end up with? A lot of you can probably do this in your head, but which equation is easy? I mean, what variable is easiest to solve for? Y. And to solve for it? Yeah. And you might be used to putting the slope part in front. Think of this as slope, which is fine. But just remember that these two are identical. So if you got negative 3x plus 14 and you're thinking, well, that's not there, what am I doing wrong? You had it right, but we're not graphing, so it doesn't matter where I put that negative 3x in the front or the back. Okay, so these two are the same. If you were thinking this, that's the same thing as D. Okay, and that's the reason I put this on here, so you can see that it's okay. It's not slope-intercept form. Okay. All right. So the main skill we're going to develop right now is which equation is easier to solve for, the first or the second, and what variable. Okay, and come up with some guidelines for making that decision. So let's say this top one is the first equation, the bottom one is the second equation. Of these, which one do you think is easiest to solve for? Second one for y. And what gives that away? Yeah, what gives it away that this is the easiest one to solve for? We have a 5, a negative 3, a negative 4, and then we have a 1. Or no number here, but it's a 1. So yeah, that's probably a good indicator. If all the other coefficients are not 1, and you have one that is just, you know, plus y or plus x, that's probably a good idea to go ahead and solve that equation for that variable. So like here we had add 4x to both sides. Plug it in right here. One step, and we can start substituting and finishing up the problem. Now, it wouldn't technically be wrong if you chose another variable, but let's just say I wanted to solve this one for x. Right? So if I wanted to solve that top equation for x, I'd first add 3y to both sides. I'd have 5x equals 3y plus 22. Then I'd divide both sides by 5. And I'd have x by itself. See? I have x equals. But the problem that shows up is now I have 3/5 y plus 22 over 5. That's not very nice to take this and try to plug it back into x. Because then I have to distribute a negative 4. Negative 4 times 3/5, negative 4 times 22 over 5, and it gets really messy really quick. But if you did all the arithmetic correct, you'd still get the right answer. If you're up for a challenge, you can purposely take something that's more difficult and try to solve it that way. But for most of us, we want to keep it simple. Choose the one that will be less work. All right. What about here? Not quite as easy because none of them have a 1. So we have to decide which one is probably the good, easiest equation to solve for a single variable. And come up with a reason for that as well. So take a look at that. Maybe talk to your neighbor. Try to figure out, well, of those two, which one is easiest, top or bottom, and then of the variables, x or y, which one is the easiest way to solve for a variable that doesn't lead to a bunch of fractions? Anybody got an idea? Yep.
The first one for x because it's positive and easily divides into 16.
Okay, so perfect answer. We say the first one for x because 2, if you think about what the steps are to solve this, you'd have to subtract 6y on both sides and divide by 2. To avoid fractions, you want to make sure whatever you're dividing by goes into those other two numbers. So 2 goes into 6 evenly, and 2 goes into 16 evenly, which means I'll have no fractions if I use that. If I tried to solve for y, which a lot of you probably would because you really like slope-intercept, you'd end up with like a negative 1/3 fraction because 2 divided by 6 will give you a third, but then when it's moved to the other side, it'll be a negative 1/3. So if you look at the bottom, 3 doesn't go into 5. Even though it goes into 18, 3 doesn't go into 5, so we don't want to solve for that. We wouldn't want to solve for this y because 5 doesn't divide into 3 evenly. So you can tell ahead of time what's going to give you fractions and what's not. So I'm mainly focusing right now just on what to pick to solve for. But remember, when you're doing this, you're going to pick, right? But then you're going to go through and actually solve the whole problem. Okay. So we have, what, negative 6 plus 16. Divide everything by 2. We have x equals negative 3 plus 8. I'll take this, plug it in for the other equation. So now I have 3 times x minus 5y equals negative 18. And my x I know is negative 3x plus 8, so negative 3x plus 8. And you can see how this now more or less looks like one of the that warm-up question we did. You have to distribute, right? You have to do variables on the same side and so on. Okay. Oh, wait a minute. Thumbs up here, huh? That should be a y. There we go. These are y's. Accidentally. There you go. Common mistake. Can't read your own writing. Those are all y's. There you go. Variables on the same side. Negative 14y plus 24. And I'll leave you to the rest just to go through and solve, find out what x is. Okay. But just remember, your goal is still to get to the end and have x and y. And probably do a check. Alright, so let's look at, oh, just a reminder, if you get all the variables to cancel out and the numbers left over are not the same, it's not true, then you know it's no solution. They're parallel lines if you graph them. If the variables canceled out and you happen to have the same number on both sides, then it's infinite solution. So you saw a few of those last night as well. And in these cases, there's no check. You can't do a check for no solution because you're checking to see if your solution's correct, but if there is no solution, it's impossible to check for it. Infinite solution means you can technically check, you could just pick any number. because they're all solutions. You could pick any x, any y, and they all work. So it's up to you, but not really necessary. All right, so let's take a look at your homework here. Have this in front of you. And let's go through some of these and decide which one is a good equation to solve for. So on number 2, which equation, top or bottom, and which variable is easiest to solve for? Okay. Yeah, well, you have two options, right? The top, that's easy to solve for. You just have to subtract 5x on both sides. So you'd have y equals negative 5x plus 8, and we could plug that in right here and go ahead and solve. So from this point on, it's the same thing we just did last night. It's just trying to get it set up so one equation is equal to a variable. Let's go through the rest of these. On number 3, which one would you like to solve for, top or bottom? Bottom, top, doesn't matter, right? They both have a coefficient of 1. What about number 4? Bottom for y. And number 5? Top for x. So we can put together a pattern here, right? If here they all have a coefficient, but one of them doesn't, or it has a coefficient of 1, there's no number there, that's probably the one we want to go with. And number 6, you might recognize that. We just did that. And we said, well, 2 goes into 6 and 2 goes into 16, and that's the only equation that does that. 3 doesn't go into 5, 3 doesn't go into 18, so we probably want to solve for x here. Okay? And all the work was on that other page. What about number 7? Which one would we want to go with? Bottom one for y, right? Because 3 goes into negative 6 and 3 goes into 3. Okay, so we'd end up adding 6x to both sides. So we have 3y would equal 3 plus 6x. Divide by 3 both sides. Y equals 1 plus 2x. And then I would take that, 1 plus 2x, and substitute in on the top equation and finish the whole thing up. So this is the only, this equation and this variable is the only one that will leave me with no fractions. Okay. And I'm not doing all the rest of it, but just remember, you're going to finish this up. You're going to go through to the very end until you get what x equals and what y equals, and then of course why do all that work and not know for sure if it's correct or not. Do another 4 or 5 seconds of work. Okay, it's right, I'm good. Okay. If it's not right, you can't find the answer, don't erase it all. Maybe just come in tomorrow and say, hey, can you find my, turn to your neighbor, can you find my error? I can't find where it is. I tried for 3 times, I just couldn't get it. You know, but you know, it's right there staring in front of you. You just gotta look at it enough times. Alright, next page. What about 8? Which one here? Yeah, top, and then in this case it really doesn't matter. You could solve for x or y. They're both equally the amount of work. So up to you, but just know that you and your neighbor could have different work depending on which one you choose, but they could both be correct. The bottom, number 9, bottom for y, good. Number 10, top for x, right? One step away, just add 8y to both sides. You have x equals 17 plus 8y, ready to go. Number 11, top for, yeah, probably top for y. Right, think of that as a -1, so I would have to subtract 5x, then divide by -1. -1 goes into 5 and into 18. Wouldn't want to choose down here because 10 doesn't go into 2. You could choose the y on the bottom, but it's a little bit more work. What about number 12? For x, but 4 doesn't go into 6. 6 doesn't go into 4. On the top, 2 doesn't go into 3. 3 doesn't go into 2. So here's that situation. Well, what happened up to this point? We've been given some nice numbers, but what happens if nothing divides, and no matter what you do, you have a fraction? Okay. In that case, we're going to skip it. Okay. For now. Tomorrow, I'm going to show you when this happens, you're going to use a different method called elimination. Okay? So the nice thing about having multiple tools is that, well, you only use that tool when the job calls for it. Okay? If you're trying to paint a wall, you don't take out a hammer. Okay? Take out a paintbrush. So depending on what you're trying to do, you take out the right tool. On this, these are set up for substitution really easily, so we're going to use that tool. But if they're not set up for substitution, there's going to be a different tool for that. We're going to use elimination, and we'll talk about that tomorrow. So if there's no way to avoid the fractions, like on 12 and 13, okay, we're going to just wait on those. We'll come back to them. We'll talk about them on Thursday and Friday and how to solve those. So you really just need to do 1 through 11, and then go down here. There's a couple word problems, just like the one we've been practicing. They even give you the equations and everything. You just have to solve them. And please explain what the answer means. Don't just say the answer is 300. Well, 300 what? $300 or 300 Blu-rays? What does that 300 stand for? You know, give context to your answer. But it's a little bit easier because they give you the equations, and this further reinforces why we need this method. Imagine if I told you to go home and graph this. Y-intercept of 502 and go up 26 over 1. A y-intercept of 920, go down 12 over 1. See where they intersect. That would take forever, right? So we need this method because the numbers get big, they become decimals, we can't graph them easily. Okay? And same thing on 15. They give you the equations, just go ahead and get the answer. Make sure you do this alphabetically. C, comma, D, right? Alphabetically. And then say, well, what does C stand for? What does D stand for? Give context to your answer. Okay? And I'll be stamping last night's and tonight's both substitutions tomorrow. So have them both ready, more or less finished when you come in at the beginning of class, minus maybe 1 or 2 things you couldn't get on your own. Okay. Okay. You have about 10 minutes or so.